What are you doing, Toad?
I'm looking through my pinhole. It is there. Can you see it?
Yes, I can.
Yes, I'm looking
It's a
through my
little
pinhole.
dot there right in the middle.
Yeah, it is. So that's what is the term pinhole? Why is it used in terms of firewalls?
It's colloquialism for opening a little hole for traffic to pass through in an otherwise impervious firewall that
Right.
is keeping all the bad guys out.
So I would imagine that pinholes can be small or large.
Well, I suppose if you think of it in terms of the amount of traffic that they allow through, if they allow sufficiently large range of addresses or protocols or whatever, I guess you could say that they can be
a nail hole,
or maybe a fire hose, but depending on how you do it. But yeah, generally, opening a pinhole is effectively the firewall permitting a certain limited subset of traffic through.
Right.
That's identified through policy or through stateful behaviour.
Look, it did look like sound like when we were talking about stateful firewalls, that it was more, in that environment, it was more about shutting as many pinholes down, potential pinholes down as possible. But we know that that's not quite enough.
Well, you can generally, and look, every firewall administrator, every experienced firewall administrator will have their own approach to the best way to do firewalling, but it's generally accepted that you collect the largest amount of traffic first in either a permission or a deny, depending on how the best way to do it is, and then you gradually filter down.
So, is that where application layer gateways start to fit in?
Not necessarily. Application layer gateways are a very specific animal.
They're still considered the first kind of the primary chunk of protection in one sense, right?
Well, you'll usually find them used in concert with a stateful firewall, an SFI engine of some sort. The thing is that stateful firewalling gets into trouble when applications use multiple connections to achieve data transmission. Now, what I mean by that, particularly some of the older protocols that we're used to seeing, FTP fits into this category, RPC, RTP, or SIP fit into this category. What they do is they have a control channel which is used to allow the endpoints to negotiate parameters over which the separate data will then flow. So, for example, you and I might have a control channel which allows us to negotiate a pair of ports that we'll use to then open a subsequent connection and pass data to each other on those ports. Now, the problem with firewalling is that when we embed that sort of information in the data stream as opposed to using it in the headers, then you need to know what to look for to be able to derive those port numbers out of the data stream to then know that you've got to open a pinhole to allow the data through.
There you go. And so we're now going beyond the realms of a standard stateful firewall.
Well, yeah, usually it's in conjunction with a stateful, but a stateful firewall on its own would probably inadvertently block certain applications or protocols from working because it doesn't expect the behavior that they're exhibiting.
All right. Well, let's talk about what an ALG actually is.
Okay. So if we go back to our original example, I'll use blue this time for our firewall.
And you're drawing it as a firewall now rather than a router.
Yeah, well, just to show
Is there a reason for that?
Mainly to show that we're sort of moving into the realms of genuine firewalls. Having said that, there is nothing to stop you from having a stateful firewall with an ALG operating in a router. So I think in the last video we briefly talked at the end about where you would find stateful firewalls, and we did talk about the fact that it often comes in, say, your home, your garden variety ADSL router.
Or a small business router. Yeah.
A lot of them will include a basic ALG as part of that functionality as well. Okay. So we might have our trusted and untrusted side here. And I'm just going to use some very basic mnemonics in the policy here. I won't get too hung up on addresses or anything like that.
Yeah.
But we might have a rule in here that says we're going to permit from the trusted to the untrusted side. Oops, untrusted. Get it right. HTTP, and then we'll have another one which might permit FTP.
Yep. Trusted.
Untrusted.
Yep.
FTP.
This is from and to.
Yes,
Yep.
so source and destination. And the stateful side of the firewall will pick up that a HTTP session was open from the trusted to the untrusted side and automatically open that pinhole we talked about to allow the return traffic for that particular session to come back. And we know it's going to track it and make sure that it all stays all within the parameters of what that session should look like. But with FTP, the difference is we now have, if we like, from our, and I'll use again just some different colors, we'll have our client on this side talking to a server out here. The first thing we'll do is when we initialize our FTP session and we establish that FTP is talking from the client to the server, there'll be a control channel opened in this direction. And of course, it'll pick that up as part of a permitted policy. The stateful engine in the firewall will actually record in the stateful table that that session's opened so that the return session is automatically permitted to come back.
Of course.
Okay, so that's all standard stateful behavior.
That's in the stateful side of things.
But in certain modes of FTP, well, first of all, FTP always uses a separate data connection. I'll use a different color to represent that. Now, the thing is, this particular connection here, and I'm just going to draw a line to start with. I won't put an arrowhead on it. But there are certain modes of FTP where it will be the server that opens the data connection back to the client, and other modes where the client will open the connection to the server. Now, if you're in a situation where you're using FTP so that you always use the correct mode to ensure that it's open in the outbound direction, then the firewall itself should be able to deal with it. But if you're in a situation where the server opens the session in the other direction, or you're using another protocol that embeds port numbers for the data session inside the control channel so that they have to be told in advance what ports to use, then that's where the standard stateful firewall gets into trouble. So what will happen is the ALG in here, so in this case we will say there is an FTP ALG in place. We'll monitor the control channel, okay, to see that the mode that's in place, etc. And then when the server, in this example, attempts to initiate the connection back to the client to transfer data, such as a file, then it will automatically be ready to open that port number at the inbound direction to allow it to make it all the way to the client. And that could even be more complicated. The other thing the ALG might be doing is if this is a natting firewall, it also has to fix the IP address up to get it to work correctly as well. So they can actually be quite smart in what they're doing here. So FTP is an example is the one that I most commonly use to explain how this is working. But as I said earlier, there are a number of other application protocols, including some more recent ones to do with IP telephony and others that work in somewhat similar behaviours. And for that reason, we need to be able to deal with those if we're going to operate between two different networks that have a firewall between them.
How else does the industry treat an ALG then?
Oh, look, in most cases, as I mentioned, you'll probably find ALG. You're not going to find them in a device on their own because it doesn't make sense to have something that's able to read a control channel just so it knows what the data ports are going to be. Maybe if we thought long enough, we could come up with a reason to do that. But generally, you'll find these embedded with stateful firewalls. The thing that you would probably be looking for is when you're looking at the specification sheet, like a data sheet for a firewall, you'd have a look at the protocols that are supported, and you would look at the list to see what type of protocols that it's able to deal with. And that will be a good clue as to the extent of support the ALG has for these, fairly complex and yet important protocols that you'll find in use in enterprise networks.
Well, you've said that it's likely to be, the functionality is likely to be embedded with whatever device that you've got that's doing your stateful and stateless firewall.
Well, depending again on the spec sheet, and that's why you would check it.
So I'm assuming that, I asked the question, where do you put one of these things? It's going to be in the same spot. It has to be.
Well, in that case, it's probably going to be in the data path for obvious reasons. And it's probably, in this example again, it's likely, but not necessarily demanding, that it sits on the edge of a corporate network, if not in other places as well. But I'll come back to the point that I made with stateful firewalling in the previous video, and that was any of these connection monitoring and control devices or firewall types need to sit in the data path to be effective. It's not like you can defer the screening behavior to something else that does it on your behalf and then sends it to you.
Right.
So when we talk about content screening, for example, we might be in a situation where we can defer the, even if we receive an email, we could send it to a content screening engine to check the email before we open the email or the attachments embedded in it.
Yeah.
And that doesn't need to be on path for us to be configured to do that. Or we might do it as part of a proxy setup where traffic is diverted that way as part of a broader policy construction. In this case, you've got to get the traffic to go through it because it needs to see the connection itself in order to be effective.
Yeah. So, Chris, are we now at the point where we can go up the stack a little bit so we can start getting into content, intrusion detection and protection, those sorts of things?
Certainly, we're probably at the point where we've gone as far as we reasonably can, sticking with connection behaviour, session behaviour at layer 4.
Yeah.
Now, you might argue that there are aspects of this that are also layer 7 based because you're able to actually look at you need to understand the protocol behaviour to understand how to pluck this info out that you need to open data sessions. But it's still a fairly rudimentary form of layer 7 analysis.
Yeah.
So, yeah, we're getting to the point where the majority of the threats these days are less likely to be that someone's trying to hijack my connection or punch a connection in that I don't expect, and more likely to be trying to trick you into opening a connection that looks legitimate and then feed you some dodgy information such as a virus or some other malicious. And look, I'm not trying to preempt the options that are out there for black hats to try and get access into networks, but I guess where we're at is once you get past this point, you're starting to say we need to be smarter about the content and the payload information rather than just worrying about how the session was constructed to deliver it.
And we get to the point where it's another device.
Could be. Although I will make the point, and we will talk about this a little bit more. There are in some of your firewall types that are doing your stateful firewalling today, it's quite common that they will also have an optional feature that includes content screening
and intrusion detection.
Or the other way around is the firewall manufacturer will say, well, if I'm building a content screening firewall, why don't I throw stateful in there because it's not really that much extra complication.
Good. Well, I look forward to seeing those.